All right, 6.3, Law of Cosines. So in the previous section, Law of Sines, we talked about what we could do as long as we knew everything about one of the letters, about A, B, or C, and at least one other piece of information. Law of cosines is the other rule we can use for solving non-right triangles, and this is the one we use if we don't know everything about any of the letters. So before, like if I knew everything about C and then I just knew one thing about A, then I could use law of sines. So I needed to know everything about a side length and its opposite angle in order to use law of sines. Law of cosines is different. So with law of cosines, if I know this side length here, this angle here, and this side length here, I don't know everything about any of the angles, but I can use law of cosines. So this would be side angle side situation. So this is a situation in which you can use law of cosines. The other situation where you can use law of cosines is if you know all the side lengths, but you don't know any of the angles. So this is a side, side, side triangle. Like I said in my previous video, I'm not really super interested in you knowing whether it's side angle side or side 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 that belongs with law of cosines. I'm more just interested in you knowing which situations belong to which in terms of I know everything about letter A, so I know I can use law of sines. Or I don't know everything about any of the letters, therefore I have to use law of cosines. That's what I'm more interested in here. So let's go ahead and talk about the formulas. So here they are. They look a lot messier than the law of sines formulas, but law of cosines has a nice property to it in that you're always going to get one answer. There's no ambiguous case, there's no trying a second triangle, there's no solutions. With law of cosines, you are always going to get an answer and you're always going to get only one. So it's a nice, it's a nice formula in that regard. But the formulas are a little bit messy. So this is the traditional setup of the formulas, and then this is the alternative way you can write it that makes it a little easier to solve for the angles. So let's just get straight to using them in an example. All right, so I went ahead and put our formulas right down here so that we could easily keep track of them. And we're looking at solving this triangle right here. We know that this is going to be a law of cosine situation because we don't know everything about any of the letters. If we try to write down what we have, so we don't have angle A, we don't have angle B, we have angle C and it's 60 degrees. We do have baby A, that's right here. And we do have baby B, which is right here. So baby A is 2, baby B is 3. We do not have side length baby C. So none of these, there's not a single one where we have both pieces of information. That's what makes it a law of cosine situation. When you're doing law of cosines, you're always starting by solving for the side length opposite to the known angle. So if you have a known angle, you want to start with solving the side length opposite to it. So in this case, that would be solving for this guy right here. Right. So looking at solving for side length C, you're looking at these formulas here. The side length C formula you want to use is this guy right down here, this C squared formula. So C squared is equal to A squared plus B squared minus 2AB cosine of angle C. When you do this, to solve for C, remember that you're going to have to take the square root of both sides. So in order to get this to just say c and not c squared, you're going to be taking the square root on both sides. Now, normally you'd need to put a plus or minus in there when you take the square root of both sides of an equation, but you don't need to worry about that here because we know that c has to be positive because it's a side length. So we can just kind of, wishy-washy, wave our hands and call it all good. So if I take the square root, I'm going to have c is equal to the square root of, now baby a, so that's 2 squared, plus baby b is 3, so 3 squared, minus 2 times a is 2, b is 3. Angle C is 60 degrees. So C is equal to the square root of 2 squared plus 3 squared minus 2 times 3 times cosine 60 degrees. Let's see, so we have 4 plus 9, which is 13. And then minus 12 cosine of 60 degrees. Of course, you could just plug it into the calculator the way that it looks, but sometimes it's nice to just simplify it before plugging it in. So we can plug in this guy right now. And you're going to get, well, the exact answer is the square root of 7, but if we're rounding it, it rounds to 2.65. So we have 2.65. Now, here's the thing. Technically, we have enough information to use law of sines at this point, and a lot of people would prefer using law of sines because the formulas are a lot less messy. However, don't. There are situations where it won't work out. Sometimes it will, but sometimes it won't, and you won't know if you're in a it will or it won't situation at all. There is not a way to be 100% positive in all cases that you have used the correct that you have the correct triangle going on, because law of sines has that ambiguous case and law of cosines doesn't. So if you run into an ambiguous sine case, it could end up that you choose the wrong triangle. Bad things happen. My dog is whining. Hold on. So anyways, dogs take care of. Once you start with law of cosines, you need to finish with law of cosines, period. If you start with law of sines, you could finish with law of cosines, but no reason to do that. But if you start with law of cosines, you finish with law of cosines. Period. Have to. 100%. And I will do a problem to show you why. So, dealer's choice on whether you solve for angle A or angle B first. I'm going to go ahead and do A. Now, to solve for the angles, so for solving for the side lengths, you're using these formulas. To solve for the angles, you're looking at these formulas. So, to solve for angle A, I want to use this formula. So I have cosine A is equal to B squared plus C squared minus A squared over 2BC. So cosine A is equal to 3 squared plus, now really C was the square root of 7, so I'm going to cheat and write this as the square root of 7 squared instead of writing the decimal expansion. The reason for that is that if you square a square root, it just turns it into the number 7 in this case, and that's a nicer number to deal with than a rounded number with decimals. Minus 2 squared over 2 times 3 times C, which is the square root of 7. So I have cosine A is equal to, this will be 9 plus 7 minus 4, so 16 minus 4, 12 on top. So 12 over, on the bottom we have 6 square root 7. To get the angle by itself, just like with sine, we're just going to take cosine inverse this time on both sides. That will cancel out those cosines. So we get angle A is equal to cosine inverse of 12 divided by 6 square root 7. Making sure your calculator is in degree mode, you're going to get approximately 40.89 degrees. Now, to get the remaining angle, that's the easy one. So to find angle B, we just have to take 180 degrees and subtract out the other two angles. So subtract out 40.89 and then 60 degrees. And that's going to leave you with 79.11 degrees. And that's the solved triangle right there. Easy peasy. So let's go ahead and look at this one. This one I didn't even bother drawing a triangle for it. I'm just gonna go ahead and write down A, B, and C here. So we're given 3 different side lengths. This is a side situation. All we are missing are the angles. Now, this is a situation, this is actually a problem a student brought to me when I was teaching this a few semesters ago. And they had used Law of Cosines, and then they used Law of Sines, and they were getting the wrong answer, and they couldn't figure out how they were supposed to tell that what their answer they were getting was wrong. And this was the triangle that convinced me that I cannot let students use Law of Sines, because there are tricky situations like this one where it's impossible to tell what needs to be done, which of the 2 ambiguous case sign triangles is the appropriate one. So let's go ahead and start. So we really have our choice on which angle we start with. I feel like it makes the most sense to start with angle A. So we're going to find angle A, and we're going to use that formula cosine A is equal to B squared plus C squared minus A squared all over 2BC. So cosine A is equal to 44 squared plus 20 squared minus 37 squared all over 2 times 44 times 20. So just plugging in those values. I'm going to go ahead and quickly simplify this piece on my calculator. And the calculator gives me 967 over 1760. To get the angle by itself, I'll take cosine inverse on both sides. So these cosines cancel. I get that angle A is equal to cosine inverse of 967 over 1760. Plugging that in my calculator, I get approximately 56.67 degrees. Now, I've already told you that if you start with Law of Cosines, you have to finish with Law of Cosines. So I'm going to finish this one with Law of Cosines and then go back and show you what happens with Law of Sines here. So we're going to find angle B using the same exact process we used for finding angle A. So we'll use the formula cosine B is equal to A squared plus C squared minus B squared all over 2AC. So I have cosine of angle B is equal to 37 squared plus 20 squared minus 44 squared all over 2 times 37 times 40, oh, not 44. C is 20. And I'll simplify on my calculator real quick. All right, so I get, let me just write this on a new line. I get cosine B is equal to negative 167 over 1480. I will take cosine inverse on both sides to cancel those cosines. And I'm left with angle B is equal to 96.48 degrees. So the last thing to do is solve for angle C. that's not a big deal because we already have the other two angles. So we just need to do 180 degrees minus the other two angles. So minus 56.67 and minus 96.48. And we get 26.85 degrees. And this right here is our final answer. All right, so this is the final and the real answer. I want to now try this using law of sine. So I'm going to copy some of this onto a new slide and erase a little bit. Hold on just a sec. All right, here I am back. Now I have erased some stuff and I've also shrank some stuff down. So you would have to start with finding angle A or finding one of the angles. So in this case, I found angle A. I got 56.67 degrees. And I am now going to find angle B using law of sines. So I'm using law of sines here. Sine of angle B over B is equal to, we know everything about A, so sine A over A. So sine B over 44 degrees, or not 44 degrees, over 44 is equal to sine of 56.67 degrees over 37. We will multiply both sides by 44 to cancel. So we get sine B is equal to 44 sine of 56.67 degrees all over 37. And then to get angle B by itself, we will take sine inverse on both sides. So we get angle B is equal to sine inverse of 44 sine of 56.67 degrees all over 37. I'm going to pop that in my calculator real quick. All right, and then when I pop it in the calculator, I get 83.51 degrees for angle B. Right? 83.51 degrees for angle B. And I should be getting 96.48 for angle B. So what's happening here is we have a situation where we have one angle to begin with, not two, but one angle to begin with, which means it is an ambiguous case of law of sines. Now, sometimes you can still do law of sines, you just have to kind of be careful about the way that the triangle looks. So, for instance, let's see if I can make this right. I don't know. It's not a beautiful triangle. So we could say that the longest side is 44, so this is B here. And the short side is 20, that was C, and then this other side is 37, that's A. And we could say because this is the longest side that this should be the biggest angle, and that because this is the shortest side that this should be the smallest angle. So if we did 83.51 degrees here, and then did finding angle C by doing 180 degrees minus 56.67 degrees minus 83.51 degrees, 180 minus 56.67 minus 83.51, I get that angle C is supposed to be equal to 39.82 degrees, and everything would appear to me to be fine. So this, right, angle C is the smallest, angle B is the biggest, angle A is the middle, and that all lines up with what should happen because these numbers are so close, right? These numbers are so close to the alternative version that's what's happening here. So it turns out that this isn't the real triangle, and there's no way you would be able to know this unless you had a ruler and a geometry set in front of you so that you can, just accurately sketch the triangle. That's the only way you could do it. And you're not going to be able to do that. I can't do that. Don't feel bad about not being able to do that. You just can't. So if you did look at the alternative B2 triangle here with law of sines, you would do 180 minus 83.51 degrees. 180 minus 83.51 degrees. And you would get 96.49 degrees, which, it's off by rounding, but that's what that angle really should be. So this is the reason that you can't use law of sines on a law of cosines problem, because there are particular situations, and this happened on a first student on a quiz on Alex. So this isn't just me making up wild numbers. This is an actual problem that an actual student brought me from an actual quiz on Alex. There are actual problems, many of them that don't work out with law of sines. So you do need to finish all problems that you start with law of cosines. You have to finish them with law of cosines. All right, let's go ahead and do one more example just so we can get a feel for it. And then I think you'll have all the tools you need to be a successful and healthy user of law of cosines. All right, so here we go. Another time where I'm too lazy to even bother drawing a triangle, but here are the numbers. Here are our law of cosines formulas, and here's what we have and what we're missing. So we can't say that we know everything about any of the letters, therefore it is a law of cosines situation. With law of cosines, if you start with one angle, you have to start by finding the remaining side. So in order to use law of cosines to find an angle, you need to know every single side length. You can't use one of these formulas without knowing every side length. So first things first is getting that missing side length taken care of. So let's find side length A. To find side length A, our side length formulas are these guys here. So we're looking at this first formula. A squared is equal to B squared plus C squared minus 2BC cosine A. So A is equal to the square root, since we're going to have to take that square root eventually, the square root of 150 squared plus 100 squared minus 2 times 150 times 100 times cosine of not angle A, but 130 degrees, which is what angle A is. I like to simplify this before plugging it in my calculator because I like to write everything down. So I'm going to quickly simplify. So 150 squared plus 100 squared. I get 32,500 minus 2 times 150 times 100. That's 30,000. Put some commas in here. 30,000 cosine of 130 degrees. And I plug in my calculator, square root of 32,500 minus 30,000 cosine of 130. And I get 227.56 for my missing side length. So now that I have all my side lengths, I'm good to find the remaining angles. I did start with law of cosines, so I'm going to finish with law of cosines. I'm going to go ahead and find angle B. To find angle B, I'm using this formula right here. So cosine of B is equal to A squared plus C squared minus B squared over 2AC. So cosine B is equal to this is going to be kind of messy, right? So 227.56 squared plus 100 squared minus 150 squared all over 2 times 227.56 times C is 100. And going to plug that in and simplify. So it doesn't simplify into a nice number, so I'm going to keep 4 decimals at least. If you wanted to feel extra safe, you might keep even more than that, but I'll keep 4 decimals here. And then I'm going to take cosine inverse on both sides to get that angle B by itself. So angle B is equal to cosine inverse of 0.8631, which is approximately 30.33 degrees. Last but not least, we are solving for angle C. Not a big deal since we already have the other 2 angles. So angle C is going to be 180 degrees minus 130 degrees minus 30.33 degrees. And that's going to leave us with 19.67 degrees. And that's that. There's our finished triangle. So once again, I cannot emphasize enough, even though it is tempting on these law of cosine problems to use law of sine since it is an easier formula, I am going to highly discourage it, and I will not have pity on you if you do this wrong on the exam by using law of sines, because you need to use law of cosines. I'm trying to make it perfectly clear. You do need to use law of cosines. That's really important. The other important thing is that if you start with an angle, make sure that you solve for that remaining side length first so that you're able to use all the side lengths in these formulas here to solve for the angles. All right, that's everything for this video. Have fun solving some triangles using law of sines and law of cosines, and I will see you in another video. All right, bye.